Again, another example, and each time I do an example, something new pops on up that's worth your while paying attention. So let's scroll through this fairly quickly and kind of get a sense of what this graph looks like. Step one, look for symmetry. You can see that f of negative x, or if evaluated, produces a result, so I have symmetry about the y-axis. Step two, y-intercept, evaluate at 0. So I have 0 over 1. So I have the point 0, 0. Step two, look at the denominator equals 0. So x to the fourth equals 0 when x equals 0. So I know I have an x-intercept at 0. Vertical asymptotes. The denominator, x squared minus 1, or x squared plus 1. Where does that equal 0 at? This doesn't equal 0 because I have x squared equals negative 1. So there's no solutions in the real number plane. I have complex solutions, no real numbers. So that tells me then that I have no vertical asymptote. Okay? Horizontal asymptote. Look at the ratio. I have a degree 4 and a degree 2. The numerator is greater than the denominator. When that happens, remember what that was? The horizontal asymptote, there isn't one. So what do we have? Doesn't look like much was going on here. So what do we have? Let's kind of draw our axis. Draw what we know. That's all we know. No vertical asymptotes, no horizontal asymptotes to help us determine what the graph looks like. I know it's symmetrical, so maybe the best thing to do is try a couple of points. And so let's see what f of 1 does maybe. That produces a 1 over a 2. And let's try maybe f of 2, sure. 2 to the fourth. Oh, maybe it wasn't there, but I want to try it. 2 times 2, 4, 8, 16. All over 5. I know it's symmetrical, so I know that f of negative 1, this will also equal f of negative 1, and this will also equal f of negative 2. So at the point 1, I have a value of 1/2. And at the point of 2, I have a value of 3 1/5. So up there somewhere. And then because it's symmetrical, I have points over here as well. And then connect those dots. So a rational function, well, looks like a quadratic a little bit there. No vertical asymptotes, no horizontal asymptotes. It means that there won't always be a vertical or a horizontal asymptote when we're doing a rational function. However, there might be another type of asymptote that we're going to explore now.